So, hello guys, and welcome back. So, today we are back with some again really good questions from the Mathsplorers Test series. And so, guys, the question that you right now see on screen is a really good question because this might look like a lot of integration and stuff, but it is actually a really good conceptual question and might come in your exams. Okay, so really noteworthy of trying. So guys, as per the tradition in our videos, if you want, you may try this question out. I will wait for a few seconds and then I will start solving this. Okay, so guys, I hope now it's time for us to start solving. So basically the first thing is, if you like read the question, then S is a set of all continuous functions such that integral 1 to 3 f of x into sine pi x by 2, this thing is equal to integral 1 to 3 f of x into cos pi x by 2, which is equal to 0. Now actually there is a point here, that is how, like, all of you know that when we integrate an expression, so if we want to represent that in a graph, then basically that means that we are trying to represent the area of that particular curve, okay, or rather area of that particular function. Now, if we see this particular question, here it is given that f of x multiplied by sine pi x by 2 and f of x multiplied by cos pi x by 2, their area in between 1 to 3 is 0. Now, if the area is 0, then there can be two scenarios. Either, like, I guess only one scenario actually, not two scenarios. Any curve, okay, any curve, if the area that it binds with the x-axis is 0, then there is only one meaning, that the curve is symmetric like this. It is absolutely symmetric. This area is equal to this area, so this area is positive, this area is negative, and so adding them up, they will sum up to 0. That is the only possibility, okay. I don't think any more possibilities are there. So guys, that basically means that if these two integrals, like if I use a better term, if these two integrals are vanishing, it means that in between 1 to 3 they have changed signs from positive to negative, and if they have changed signs from positive to negative in between 1 to 3, it implies that they have to cross this x-axis at least two times. Okay, I hope you can understand, because if they have to change their signs from positive to negative, both these functions in between 1 to 3, then they have to cross the x-axis at least two times. First will be a root. Okay, first, I guess the first one will be a root, and the second one will be the point at which the sign changes. That's the, like, reason why these two have been given to be equal to 0. Okay, so guys, like, there can be a small confusion. I just said a while ago about crossing the x-axis two times. Now, a genuine question in your minds would be, which one I am talking about? Am I talking about f of x, or am I talking about these complete functions? Okay, so that needs an explanation, a very good explanation. So basically, guys, like, if you do a little bit of putting points, okay, if you put random points, say x equal to 1, x equal to 2, x equal to 3, so that then you will notice that like, if I consider this particular full function, okay, it means that if for the integral to vanish, I already said fx must change sign. But problem is that if I divide the number line into two intervals, say 1, 2 and 3, if you put 2 into both these, like, sine pi is obviously 0, so for the first function this will be a root. Secondly, if you put 2 here, then cos pi is, I guess, -1, so this becomes integral f of x is equal to 0. So actually, if you use intermediate value theorem in both these examples, then you will understand that because the integrated expression has, like, it's changing a root one time, it's crossing the x-axis one time like this, howsoever it may be, so that would actually imply that for f of x equal to 0, there would be two distinct roots, obviously in between your 1 to 3. Okay, I have used, like, this is nothing complex. I have plain simple used intermediate value theorem and nothing else. Okay, don't complicate. Okay, now guys, there can be a much better, like, if I try to explain in a different way, I am exploring different types of ways because this should get into your minds. Basically, one thing that you will notice is sine pi x by 2 and cos pi x by 2. These two functions individually. Okay, I'm not talking about f of x right now. Sine pi x by 2 and cos pi x by 2. These two functions themselves, you can understand, they will have obviously have zeros in between this interval. That is 1 to 3. Okay. So say if a situation happens like somebody tries to argue that no, this is not two distinct roots. There will be only one root for this particular function f of x. Okay, somebody says, then how should you contradict? Basically, if there is one root for this particular function f of x, then that would mean that f of x would either be greater than equal to 0 or your f of x would be less than or equal to 0. But this sign won't change. Only one of these would happen and this sign would remain constant throughout the interval. Okay. And if that happens, that means that it will never change sign, and obviously sine pi x by 2 and cos pi x by 2 will also change sign only once in this interval, right? Basically that would mean that it's a contradiction basically, because then the area would not be 0. Why? Because the graph would be something like this. Say if this is 1 2 3, the graph would be something like this. So there would be some area rather, right? So from both sides, actually, this happens to be a contradiction. So from there, we can say that one root can't be there. If anybody argues, then you can use this as a good justification, right? Rather not justification, you have proved it. Okay, so guys, that actually shows us, if you see option number A, it says that your, if I read the option once, it says that for any function f of x equal to 0, I mean f belonging to s, f of x equal to 0 has at least two distinct roots in 1 to 3. So yeah, option number A is correct. And obviously at least two distinct roots. Why? Because like, if we take a better case, say it is above the x-axis once, goes below, again comes above, then goes below. So that can be a case. In that case also, maybe there's a possibility of area being 0. Okay, lot of things like that, but we have to consider the least. So at least two distinct roots. Okay. Anyway, so guys, this was option number A. Now let's proceed to the next options. Okay, so option B, if we give a small rating, it says if f is belonging to s is differentiable in 1 to 3 both open, then there exists a point C belonging to 1 to 3 both open, such that tangent to y equal to f of x at x equal to c is parallel to y equal to 0. So let's prove this. I guess this will be easy. Wait, guys. Yeah, so f is differentiable on your 1 to 3. So basically, in option number A, we saw f of x has at least two distinct roots. So if we take those two roots to be, say, small a and small b, then a comma b belonging to 1 comma 3 will exist, such that, or for which, f of a is equal to f of b is equal to 0. So now plain simple, okay, f of a is equal to f of b is equal to 0. So by very famous theorem, I guess you can guess what I will use. I will use Rolle's theorem. By your Rolle's theorem, C belonging to open A to B, like there will be a point C belonging to open A to B, for which f dash C will be equal to 0. I hope you can understand, right? Both of these are roots. So Rolle's theorem application. So basically, if f dash c is equal to 0, then c belonging to a to b is obviously, like, this is the slope of tangent. Slope of tangent. So that thing becomes equal to 0, which means that the tangent is parallel to x-axis. Okay, this was a very easy option, guys. Like, they have only complicated with the language. Okay, otherwise it's easy. So option number B is also correct. Okay, now moving on to option number C. Okay, so guys, moving on to option number C. This is actually the most interesting option. Okay, so the option number C is actually says that there will exist a non-zero quadratic polynomial. I'm writing the statement because that's important. Such that, or you can also use the symbol of for which p of cosine pi x by 2 is belonging to S. Okay, now if p of some quadratic, like p of x is the quadratic and p of cos pi x by 2 is belonging to S. So first thing is, because it's a quadratic polynomial, so what we will do is we will take p as a function of say t to be equal to at square plus bt plus c. Okay, first thing. Okay, now second thing is, if this belongs to S, it has to actually satisfy both the integrals, that is integral 1 to 3, and I guess this will be your p of cosine pi x by 2 within the brackets, and outside you will have sine of pi x by 2 dx is equal to integral 1 to 3 p of cos pi x by 2, and outside you will have cosine pi x by 2 once again dx. You have to prove that both of these are equal to 0. If you prove it, then I guess your points are worth being noted. So guys, for that what I am going to do is I will set theta as pi x by 2. So basically dx is nothing but your 2 by pi d theta, and if you do the substitutions part, this integral, complete integral equation, or rather set of integrals, will completely transform into pi by 2 to 3 pi by 2 p of cos theta into sine theta dx is equal to your integral pi by 2 to 3 pi by 2 p of cos theta into cos theta dx, and you have to prove this thing now to be equal to 0. Okay, so guys, what we will do is we will take this particular integral to be I1 and this particular integral to be I2 and further evaluate. Now thing is, if you see I1 carefully, if you substitute u as cosine theta in I1, then what will happen is both these limits will come to 0. Okay, so basically this particular integral, which had its endpoints up till now in pi by 2 and 3 pi by 2, using a small substitution I collapsed the entire integral to a single critical point, that is 0. So basically it will obviously be 0, right? Like you will not get pretty much something from here, so I just told you the step. Both of them will come to 0, the upper and lower limit both. That's for I1, but for I2 actually, if we go on solving, we will get a linear condition. And if that's a linear condition, like, that will give us a lot of information about whether this particular statement is correct or not. So guys, proceeding with I2. So I2 is nothing but, and p of cos theta, I hope you remember, it is at square plus bt plus c for p of t. So basically this integral will become nothing but integral pi by 2 to 3 pi by 2. This will be first cos cube theta d theta. Next, this will be b times integral pi by 2 to 3 pi by 2. And I guess this will be cos square theta d theta. And last but not the least, pi by 2 into 3 pi by 2. This thing will be cosine theta d theta. Okay, so this is the breakdown. And guys, what I am doing is I am not going into the solving. These are all standard integrals you have done in your intro to integration. Like many people do this in basic maths during class 11 also. Okay, so like pretty easy integrals, so I am not going into solving them. Okay, so basically guys, if you solve this, I will tell you the final values. This will come out to be minus 4 by 3a plus pi by 2b and minus 2c. Okay, So that's the linear relation, guys. And first thing, like not first thing, actually the last thing is I1 is equal to I2. Now you can't deny this particular thing. Okay, we are proving it for equal to 0. That is the part we are proving, but you can't deny that these two integrals are equal. It is already given. So basically if that is given, then it means that this thing will also be equal to 0, and this is the equation we needed. Okay, now basically, guys, just think once. If a single linear equation in three unknowns, okay, single linear equation in three unknowns, if this has arrived after the integration, then there can be only one meaning for this, that there will be infinitely many non-trivial solutions. You should be careful. Okay, I can easily give you, like, to complicate the question more, I can give you an option telling that I would not say a quadratic. I would say there would be a linear relation like this in between your, like a linear relation in between the, what should I say? A linear relation in between the various coefficients of the terms in the quadratic equation that is to be arriving. And I will say this linear relation will have trivial solutions. That can be a question. Okay, you should be very careful. Like, why is it infinitely? Infinitely, I hope you can understand. Now, many non-trivial solutions. Non-trivial solutions, why? Because if we had a single equation also, we could have shortlisted out something. But here, there is no, like, no scope at all of shortlisting any particular solution. So for that, A, B, C can be anything and everything. That's why it is non-trivial, okay? You can see a little bit of application of system of equations also. Like every chapter is interconnected, right? As we go forward, every chapter comes coming and you don't even realize when it comes in and goes. Anyways, so guys, I hope option number C will also be correct. And if you want to, like, if you are not still satisfied, you want to construct one quadratic, then I can do that. P of t, you can take, say, if you set a as 1, it is t square, and set maybe b as 0 and c as minus 2 by 3. So t square pt equal to t square minus 2 by 3. Now in place of this, if you substitute cos theta, again integrate, then you will obviously get it everything. Okay. This is for the people who are taking one particular example, but my result is a generalized expression. Okay. So let's move on to the last option. Okay, so in the last step, guys, like in the last option, option number D, they have said that gx is equivalent to cos pi x will be one of the functions in this particular set S. Like this will belong to S. So to check that, very easy. Integral 1 to 3 g of x into sine pi x by 2 dx is equal to this will be equal to integral 1 to 3 cos pi x into sine pi x by 2 dx. Okay. Okay, so guys, basically what I will be doing is really simple. I will convert, like I will do a half into 2. So this became a trigonometric product, and you will transform that using your transformation into like a form in addition. So basically that form will come out to be half integral 1 to 3 sine 3 pi x by 2 dx minus of half integral 1 to 3, and this will be sine pi x by 2 dx. Okay, subtracting these two. So basically you can understand these two integrals are nowhere going to be equal, right? One will be in the your denominator, one will have 1 by 3 pi and the other will have 1 by 2 pi. Or I guess, no, sorry, not 1 by 2 pi, 1 by pi. So basically no at all chances of this being equal to 0. So it means gx doesn't belong to S. Okay, gx doesn't belong to S, but option D says the opposite. So option D is wrong. So guys, question done. Correct answers for this question are A, B and C. Okay. Really good question actually, especially the option number C was very interesting. Anyways guys, this will be the, I guess, end for today's video. So if you have liked my channel, do like, share, and subscribe. Anything, recommendations, doubts, or anything, do come out to my comment section. And obviously, do join my Telegram discussion chat because a lot of people are there who are interested in JEE. So that's it for today, guys. I hope you have liked my video. Let's end this video here, and thanks for watching.